Hello, I wanted to thank Matt and NodeJS for having me. Can you hear me? Because I'm really short, so. Is that good? That's better, isn't it? Okay, cool. So I am holding a weird contraption here. Normally I actually wear it and put it on my head, but I can't because I didn't get the cover back on in time. But I'm just gonna hold it up anyway, and I'm gonna show you how to interact with this while you're actually presenting, while I'm presenting. So if you get really bored, you can just not listen to me and play on your phone. So I'm using this here that I made, which is a tiara, as an example of how you can use Node.js to control hardware directly from the cloud. So no wires, no kind of local connection needed or anything like that, just like Wi-Fi and Node.js running in the server. So a little bit about me first. My name's Hinton. I'm a technical evangelist at Microsoft. It's a super cool job. If you want to talk to me about it later, come and find me. I'm an open source hardware author, so I work on a lot of Node.js hardware-related libraries that are in use by companies such as Arduino themselves, which is really cool. And I'm also a member of the Node.js hardware working group, and we try to argue that hardware should be a first-class citizen in Node.js. So we tend to meet not super frequently, but we try and talk about how we can make sure that all of our hardware libraries, especially our native modules, work with every single release of Node.js, which is really important. I also co-authored a book with a whole bunch of other really fun friends who are also co-authors called Make JavaScript Robotics. So if you're kind of interested in this sort of stuff and you want to explore it further, then there's definitely resources out there. So I'm sort of calling this an IoT tiara. I don't really know what else to call it. So essentially, at the heart of it, the microcontroller that's powering this is the ESP8266. And that is a Wi-Fi-enabled microcontroller, and it can run either Lua or it can run C++, which is really cool. And just like a hint, if you go to aka.ms/tiara, you may be able to control the color from the stage, unless it's dropped out already. I don't know whether it's working. So feel free to try that. If it doesn't work, then I can just do a demo later. Oh, there we go. It's happening. So this is a 3D printed band that I 3D modeled. And then I 3D modeled the crystals as well. And I chose kind of like this transparent, really cool T-glass filament just to show those lights. I might turn it around so it's a little more crazy. And I'm using just three RGB LEDs. They're all in series, so you can't uniquely address each one individually, but a later version might be able to do that if I was to create this again. So I want to quickly explain all the different pieces that go into this. This is awesome. Thank you so much for playing with it. I feel like I'm in a disco on the stage. So it essentially connects to an Mqtt broker, and I'm going to explain really quickly what that is. And then there is a Node.js server that's just hosted in the cloud, and that's actually sending the commands via the website that you're accessing to the broker itself. So just really quickly to go over the microcontroller in a bit more detail, it's a 32-bit processor. It's not as fast as your other 32-bit processors you're probably used to working with. It only runs at 80 megahertz, but it is pretty cool. It does have a lot more memory than other microcontrollers have, so it's 1 megabyte. As I said before, it's Lua and C++ enabled, and the price is really, really low. So that's also why there's a huge appeal in this, because I can spend $5, put this in the tiara, and then solder everything together and be okay with not being able to use that for anything else. I can just go and buy another one. I know that there's a bit of financial privilege there for me, but it's nice to be able to have something at such low cost. And it has built-in Wi-Fi, and it is powerful enough to do TLS 1.1. So it won't do 1.2 at this point, but they're working on it. But TLS 1.1 is not too bad. So it's good for online portable low-power projects. This can run on the battery that I have in it, it'll run for at least 4 hours of heavy use, which is pretty cool. I don't know how much I charged it beforehand, and all of you are hitting it pretty hard, so we'll see if it lasts. So you're probably wondering, what is Mqtt? Because that's not usually a transfer communication protocol that you're used to working with every day if you're a web developer. So it stands for Message Queue Telemetry Transport. It's specifically designed for devices. So it's designed to be able to send lots of tiny packets of data very frequently. And so if you have sensor data from soil moisture or humidity, or if you have a factory that has a whole bunch of sensors to make sure the machines are working and the temperature signature is correct, you're going to want to send that data really frequently, and then you're going to want to be able to process that really fast too. So Mqtt was designed to do that. It's a really nice spec because it embraces the publish-subscribe model. So if you've ever used any kind of pub-sub stuff, I think React and Redux has kind of replaced that model in front end now, but I remember like 5 years ago using pub-sub a lot to do with jQuery events and things like that. So essentially you set up topic endpoints, and you can set up multiple endpoints, and then you can like publish to them, and then you can also subscribe to receive the data from them. So it's kind of a push-pull kind of mechanism, and it's really, really cool. So an Mqtt Broker is essentially kind of like a server that handles the incoming and outgoing telemetry. So I'm going to show you a few examples of how you can get a broker up and running to start doing this stuff. So the most popular broker out there, and one of the kind of most complete brokers out there, is called Mqtt. It was written by my friend Matteo. He's really, really cool. It's essentially a Node.js Mqtt broker, and you can essentially host this in the cloud wherever you like, and you can set it up to be able to have different endpoints, and so you set up the topics yourself, which is really cool. It also has one of the most adorable logos I've ever seen for any open source project. I want something as cute as that for all of my projects. So that can be a little bit of work, and you have to maintain that server. So if you want to be lazy, you can use a cloud-based broker. Because I work at Microsoft, I tend to be more excited about embracing their technology. So one product that we have is called the Azure IoT Hub, and that's essentially an Mqtt broker. And so that takes all the pain out of setting that up yourself. But the downside of using like an external service, such as Azure IoT Hub or AWS has an IoT broker as well, is that they can cost money. What I like about the Azure one is that you can spin up one instance and you can get 8,000 messages a day for free. So I never go over 8,000. We might tonight, but I tend to use it for that, and I don't usually end up paying any money for it, which is really cool. So that's kind of how you can get Mqtt going, because it's, as you can see, it's a really fast protocol. This is kind of how I put the example together, and I promise that skateboard is going to make sense really soon. So I created a colorpicker.html file, and that's kind of the buttons that you're seeing, that you're pressing on. What essentially happens is the Node.js web server that is serving up that static HTML page is also opening up a WebSocket connection to it. So every time somebody presses one of those buttons, it sends through like the color word or the color code, I forget how I coded it, and it sends it through the web server. That web server can pick up all of those requests, and then it can then send like a custom binary packet to the IoT Hub and tell it to send it straight to the Tiara. So that's kind of like the bit in between, where there's some really good C++ libraries for Mqtt specifically. So that's also why I chose that protocol, because it's really easy to get started with it. So on the Tiara side, I'm running the C++ to subscribe to that topic endpoint, and then to pick up the colors and to drive the LEDs. So I have a couple of slides of code just to show you that it's not a lot of code to get started. This is C++, but as you can see, it's super readable. And I am using Arduino C++ libraries, which make it all the more better. So I have a function where I'm setting the, so these RGB LEDs actually are just comprised of 3 LEDs inside of it secretly. And so you end up kind of like lighting up 3 different colors at once, and then the light mixed together to produce the color that you want. So I'm writing to the red pin, the green pin, and the blue pin, and because they're all in series, I only have to write to like those 3 colors, and every single LED, RGB LED will pick up that triplet of colors, I guess. Then I'm just showing my callback here, which is actually the callback when you've subscribed to a topic and you receive a message. That message is just a payload of 3 bytes. The first byte is red, the second byte is green, and the last byte is blue. And that's just a value between 0 and 256. So it's kind of like hex color codes that you'd be used to. It kind of works like that. And then just to explain how I set up the WebSockets, one of my favorite packages of all time to use for this, because WebSockets can be really tricky, is called Skateboard. I would highly recommend you check it out. It has super quick code to get up and running. So this is my, what is this? This is my front-end code. So I am starting up a Skateboard instance, and essentially that gives me a stream object, and then I can subscribe to that stream for data coming through. So, excuse me, what I'm doing is every time someone pushes one of the buttons, it gets, I have like an object with all of the hex colors and stuff, and I'm just using the ID of the button itself, which is usually just a color name, and I'm just fetching out that hex code and sending it through to the Node.js server. The Node.js server will then grab that hex color code. So for example, if it's EFB1C3, I just have a chunking function which splits it up into like the R, the G, and the B values. I then pass it through my color buffer function, which essentially maps through those strings and turns them into actual binary data, which is base 16. So yeah, like JavaScript doesn't have the greatest tools for creating and manipulating binary data, but that's kind of how you do it with WebSockets, because you can only send strings. And so I'm returning a new buffer, and then I have like a Azure IoT library, which allows me to just package that binary data up into a message to be sent along the wire. And so that's also what's nice about using libraries or like Mqtt brokers that are already set up for you. They tend to come with their own SDKs too, which is super nice. So yeah, the stream.onData gets the color that comes through, transforms it into a message, and sends it to the tiara. That's pretty much like the only code that you need. I have simplified it a little, but a lot of it you can logically step through yourself to see how it's working. And so that's pretty much it, and I know that was really quick, but if you've got any questions, please do come and see me or ask me now. If you want to know some resources to get started, I'd highly recommend going to the Arduino website. Check out adafruit.com, because I pretty much bought most of the electronics for this, if not all of the electronics, from Adafruit. It's a wonderful website, and because they're based in New York, if you order ground shipping, it's probably going to come the next day, which is awesome. My IoT Tiara is up online on GitHub, and then I have a separate color picker GitHub repo too that I forgot to put up, but I can tweet that out. And yeah, if you were interested in looking at the Azure IoT Hub too, I've just thrown the link in there. So yeah, I hope that was helpful, and thanks for having me. Yes.
So how does the Tiara and the website find each other? Somebody has a hard-coded address?
Yeah, that's a really good question. So what's great about this is you don't have to have MAC addresses or any unique identifiers. The commonality in between is that Mqtt Broker. So if the Node server is publishing messages to the IoT Hub is able to pass that on to any devices that have connected to it, if that makes sense.
So if you have multiple Tiaras in the room, they'd all be lining up as we were pressing the button?
You can definitely push it out to like I guess a Firehose topic, but you can also make different topics per devices, and then you can set the device up to just subscribe to its own topic. And usually it could be something like /tiara1/tiara2. So you can do it both ways, which is really cool. So it's a really cool spec. I think it's like mqtt.com or something is the spec. It's really cool to read about. Great question. Matt.
Yeah, a question about network segregation. Has Mqtt figure out like when you reconnect, to open up like a socket, or like, what happens if you wanted it to be queued or you miss it? Do you document at that time?
Yeah, so essentially it depends on how it's set up. I'm not sure how the Azure IoT Hub broker is set up, but I do know that you can listen on the logs and you can see when messages failed. So I don't know whether it actually retries it, but you can get that out of the logs. And it's possible that so every time I send a message from the Node.js server, it will tell me whether it successfully got to the device or not, because the pub sub model, the device will actually let the Mqtt broker know it got there. So I don't know if that can be handled on the deeper down level, but if it's not, it seems like there's reasonable like steps in place where you can actually handle it yourself too. That's a really good question. I might actually go away and research that and get back to you. Yes. How hard is it to get the tiara to talk back to the server? depends on what it could do. Maybe there could be an accelerometer in there, and it tells you whether or not I fell over. But it's just as easy to publish back to that MQTT server and like choose a topic to publish to as it is for the device to subscribe to an endpoint to. So the libraries that are there are kind of make it just as easy to do both. It just depends on like what you would want to post from the Tiara. Do you have an example? Yeah, falling over, yeah. So that's just as straightforward. It's like one line of code. It's pretty much mqtt.publish and then the packet that you want to send. These are great questions, thank you. I think that's it, thanks.